What? I don't know what happened, but they all broke.
Okay. So at the end of last class, I remember posing a question. Can somebody remind me what the question was? We're talking about the voting problem.
Oh. Was it how do we solve the problem of one person submitting more coins into a wallet than...
Well, here, let's go this route. So if I draw a picture here, and again, we'll just use our simple example of candidate A and candidate B. All right, and these are individual Bitcoin wallets, these two guys. All right, then we have the blockchain. That all transactions go through. And some of those transactions are going to end up going to the wallet associated with candidate A. Other transactions will go to the wallet associated with candidate B. And then other transactions will just go other places, right? So one of the things we talked about last time is an advantage of using a public blockchain like Bitcoin is that this blockchain doesn't necessarily have a vested interest in voting. We just happen to be using it for voting. Nick came up after class and was asking the question, well, why don't we just create our own cryptocurrency specifically for voting? We certainly could. So now this would no longer be the Bitcoin blockchain, it would be the Votecoin blockchain. Now, there isn't anything necessarily wrong with that, but first of all, we go back to the 51% problem. If you have more than 51%, if one person, one pool, if you will, has more than 51% of the computation power for adding stuff to this blockchain, they could potentially rewrite that blockchain. So let's just say that I came out with this great idea for voting and I decided to come to all of you and said, okay, we're going to create this brand new cryptocurrency called the Votecoin specifically for voting. And I need to convince you guys to start mining it. Are you going to mine Votecoins for me? For validating, because mining is required, right? Remember for the question of the midterm, we asked the question, is mining needed? Mining is required in order for new coins to be created as well as validating transactions. Okay, so from a new coin creation perspective, we only need enough vote coins for the number of total votes we might have. That's the only number of coins we need. But in the end, we still need to validate those transactions in order for them to actually end up in their final wallet. Go ahead.
You made your own currency, would you have to couldn't you alter it so that coins were not born through mining?
Oh, you certainly could. I mean, I don't think that necessarily matters. It's not a problem if we have more coins than we have votes.
Well, I was just thinking that if you had like a certain amount of coins, then let's say the government has the coins.
Okay.
Then then you have to, like today, you have to register to vote. Then when you go register to vote, they send you a certain amount of coins, one coin.
Okay.
And then that is your vote. So you send that one coin to one or the other places, then you wouldn't have this idea of over-voting.
Okay, fine, but let's say I'm the guy in the middle who's decided, you know what, I want to corrupt this election. So I'm going to be the only guy mining, just as an extreme example, I'm going to be the only guy mining these vote coins. So I don't care how you vote, you vote, you vote. I'm going to rewrite the blockchain the way I want it to be written so that whoever I want to win wins. That becomes a weakness of having our own coin specifically for the job of voting. unless I can convince a large population, or at least a reasonably large population, to mine the coins so that not one person can choose to manipulate the vote. Does that make sense? So if I just created a brand new vote coin, could I convince you guys, let's just say that you're each individual folks all around the world. You're not like a group of people who sit there and talk to one another. Can I convince you, each and every one of you, to mine vote coins for me? It's going to be on your power bill. A vote coin is worthless. What's in it for you? Okay, fair enough. You might be able to find a group of people who would be willing to donate electricity or something like that and computation resources to go towards not corrupting the blockchain. But what would keep one organization? So would we agree that you're going to have a relatively small number of people we're going to be able to convince of that, right? So let's just say you have a big, let's just use a lobbyist as an example. So the one of the gun lobbies, so they're pretty big swayers of votes. What keeps them from just buying a vote coin mining farm, getting 96% of the entire mining power, and now votes just go the way they want it to go? Problem is, when you create your own coins for a specific task, it's manipulable. Manipulable? I think that's a word. Probably manipulatable, but I like the way I said it. It's kind of fun to say, manipulatable. Yeah, sort of. So, in any case, that's why I think utilizing a public blockchain like Bitcoin, or if you don't want to use Bitcoin, you can use Litecoin or or Dogecoin, some coin that's used for other reasons. Because people are mining, and I think Bitcoin makes the most sense because it's not hard to convince people to mine Bitcoin. We don't have to convince them to do anything. They're already doing it, right? So we already have thousands and thousands of people who don't even know we're using it for voting. We don't have to discuss how how our algorithm for validating votes works. Now, having said that, it's never okay to base the security of anything on a secret. So just because if we're doing this algorithm, we're saying, okay, well, we're going to send 1 Satoshi per vote, something like that. It's not okay for us to say it's secure because the bad guys don't know that 1 vote equals 1 Satoshi. Or the bad guys don't know the destination wallet address. They don't know A's wallet address. Because those are publicly available pieces of information. Just because they don't know it, just because we're not publishing it somewhere, doesn't mean they can't find it. So we don't want to rely on that being, the security of the system. We should assume that anybody who's not legally voting knows about the address of A. They know about the address of B. They know about our idea of 1 Satoshi is 1 vote. They know all that stuff. Okay? So we have to think about securing it within that. So one way to secure this is to use a public blockchain like Bitcoin, where we are leveraging something that's in existence, whether voting exists or not. And we just happen to be inserting transactions into that blockchain. Make sense? Now, playing devil's advocate, what happens if Bitcoin goes away? What happens if we build the entire voting infrastructure on top of Bitcoin's blockchain, and then Bitcoin goes away?
You go to the next cryptocurrency that's based off of SHA-256.
Okay, so as long as we're using SHA-256 as our basis, it doesn't matter which SHA-256 currency we use, right? Because the blockchains are going to look the same. Okay, how often blocks get created might be different, but the chains themselves are going to be in the same format. Okay, so going the other direction, playing devil's advocate again, let's assume that we did decide to come up with our own vote coin, a coin specifically for voting, where now we don't have to worry about whether or not Bitcoin stays around. vote coin will stay around because we say it should stay around. We're using it for a purpose. We're under no illusion that vote coins. You're not buying food with vote coins. You're casting votes with vote coins. Okay. Are there steps that we could take to secure the blockchain? Go ahead.
I was thinking about this. My idea would have been to create a login page that everyone's taking from one wallet, but once you log in and supply like social security and say your driver's license number or something like that, then you could just press who you're going to vote for, and it sends that fraction of a Bitcoin to the new wallet. And that way you can see in the blockchain, okay, everything has come from this one wallet. Anything that has come from another wallet is obsolete. Like doesn't count as a vote. It has to all come from one wallet to one destination wallet.
Okay, but how do we know somebody isn't rewriting the blockchain?
You would outsource your mining by putting some like initiative to do it.
Okay.
So say the government would pay the first 700 people to verify the blockchain $25 each or something like that, and that's all they need is like the verification only needs 700 people to verify it. First 700 to verify it get paid.
Okay, well, so let's say that this is our distribution. These are all those people you've approached about mining on our Votecoin blockchain. Okay, so these are all the slices of pie. So we have a couple of these dudes here. Here's ghash.io, which used to be the biggest. It's actually interesting. Discus Fish is now bigger. Yeah, it's actually. I wasn't even aware of this. It's interesting how ghash has fallen. This guy right here, at one point in time, had 51%. They've had that many people leave ghash. So in any case, we're going to say these are our various mining pools or individual miners. It doesn't matter if we call them pools or not. They're a source of potential victory. These are our potential mining pools for the blockchain associated with our Votecoin. Now, this is a pretty good distribution. Nobody has close to 51% of the pie, right? We have 25% there. We have 26% there. And all these other ones are fairly small. BTC, man, this used to be one of the big ones too. It's actually interesting how...
That unknown with the specific address, does that mean that's one person?
Which one?
The unknown with one ACAJ9.
This guy?
No, yeah, down.
Yeah, maybe that's just a dude. This guy's out in South Dakota somewhere. An abandoned airline hangar. Yeah, he's got 4% of the market as an individual. Could be one dude. Yeah, I don't know for sure. But in any case, so these are all, we are looking at these as individuals who are mining Bitcoin, right? We can think of these as individual people or pools, it doesn't matter. All right, now, we look at this and at a glance, we're like, oh, we don't have a 51% problem, right? Like, oh, okay, well, nobody has more than 26%. This is the big guy right here, Discus Fish. Just, I don't know, weird name, but whatever. How do we know that this guy, and let's just assume this guy had a name other than just unknown, how do we know that these two guys aren't in cahoots? Together, they're 51%, right? So if they agreed together to manipulate the blockchain, could they do it? They could. That's basically like one big pool that has 51%. We don't know their motives. Similarly, if we took all of these guys here, Let's just assume it's 51%. I don't know that it actually is. It's not. It's less than 51%, but let's just assume it is. All these guys down here, fine, there's more, but what if these guys are all in cahoots? They can manipulate the blockchain. So a danger we have in creating our own currency for this is now we have to secure a new problem. Whether or not the people who are mining these coins are in any sort of discussion with each other. Now, having said that, and we talked a little bit about this earlier in the semester, about this 51% problem. How does the 51% problem work? If one place has more than 51% of the mining power, they're going to win often enough that they can rewrite the blockchain. Okay? Now, just because they rewrite the blockchain, does that mean they won't get caught? Those are two very separate things, right? So, I mean, we can go and cheat at something, but it doesn't mean we won't get caught. One of the benefits blockchain technology has is that it's public. Anybody can keep an eye on it. Anybody can have oversight. Correct? So we can go back and look at various iterations of the blockchain and see when a change was made. And then call them on it, essentially. And the issue you have, though, is reversing transactions isn't really possible without actually rewriting the blockchain. And that brings its own danger in. So if we go in and literally try to fix the blockchain by deleting transactions and reversing them, how do we know that that person who's fixing the blockchain isn't then also manipulating the blockchain? You know what I'm saying? So this whole idea of who controls the blockchain becomes problematic. Go ahead.
So why can't you do something like how you're chosen to do jury duty? Instead of jury duty, you have hashing duty. And you're selected as a requirement as a citizen of the United States to do it, and you get paid, and you have some sort of access to do it on some machine that is given you. I mean, maybe one day we could do it from our phones. I mean, just a little bit of hashing power on our phones could solve that problem of spreading the wealth of hashing.
Okay. What if you weren't given the choice? What if built into, let's just take the two major operating systems for cell phones, take Android and iOS. What if built into those operating systems was a kind of a micro hashing engine? We don't need to think about high horsepower. We only need a lot of horsepower for hashing something if it is, if there's this competition like we have with Bitcoin, right? If we keep it small and keep the difficulty low, we don't need to use very much battery life, just to give some processing power. Idle cycles thrown at the problem. Maybe it's not the mobile devices. Maybe it's we work with Microsoft and Apple and build it into the desktop operating systems. So things that are tethered to the wall. Behind the scenes, just like we have things like distributed.net and what's another one? Folding at home and SETI at home, searching for the aliens, where it's using your idle cycles. It's just doing its little mining thing in the background.
I don't know if we talked about it in class or if I read it somewhere else, but there was like a guy who built in mining underneath a free Minecraft game. So people were downloading, torrenting it, and actually underneath the game, it was actually mining bitcoins.
Right, and he was doing it as it was almost like a virus.
Yeah.
Where he was distributing the software. Now everybody, this guy had 10,000 people's personal computers mining for him. Each one was mining real slow, because it was doing CPU or GPU mining or something like that. But they were all going to this one dude's wallet. Maybe that's this dude. I mean, this is the guy. This is the Minecraft Minebot guy. So the larger percentage of the population that we hit, the less likely it is that 51% of those people are going to get together and corrupt the vote. But do we kind of understand this problem? Is one necessarily better than the other? If we leverage the Bitcoin network, where the people who are using the Bitcoin blockchain have interests, at least many of them, most of them probably, have interests beyond our stupid little voting app, right? But that's actually security for us because we're just leveraging that thing. We're, using that public blockchain for sending these votes. We don't have to worry about somebody having this secondary motive of hurting the voting system. Now, having said that, let's just say we were using the Bitcoin blockchain. Right now, nobody has 51% of the mining power. Well, Discus Fish, how many of you have heard of that company? None of us, right? Ghash.io just from this class. KNC Miner, maybe from some of the things, post. BATC Guild. These aren't mainstream companies, right? If a big company or a big, like the gun lobby, decided they wanted to come in and fund a Bitcoin mining operation, could they probably throw enough cash at it to have 51% of the market? So is the Bitcoin blockchain really any safer? It's probably harder for them to do that. It'll cost them more money, so that's a distraction. Go ahead.
The only way that I see it being safer is because of, so say they were to come in and put money into slush, and they get 51%. There's still all those other miners that are going against that, so it would be harder to get to 51%. I mean, it's an active mining cryptocurrency right now. If we were to create our own, you'd actually have to create the base of mining for it before you could even use it as a voting, as a viable, secure voting application, I guess.
What makes Bitcoin secure? We're going back to like the first couple of days of class. We talked about some of the features of Bitcoin. It's decentralized. Nobody gets to decide when more get made, right? Transactions are public, so it's transparent. For our intents and purposes here, I think the real security of using Bitcoin, or just blockchain in general, for this problem is the fact that it's public. Everybody who's interested can look at it. We just had a big vote yesterday. And fine, we watched the news and saw the results and stuff like that, but none of us got to watch the actual votes as they were tabulated. We just believed whoever said the vote was what it was, right? So, is blockchain technology secure because it's public? Is that one of its features?
You can at least realize when you're being tricked.
Yeah, I mean, if a bank, if the walls of a bank vault were glass, where you can just see through it, could somebody still rob that bank? Sure. Would everybody be able to see that they're robbing the bank? Yeah, absolutely. You wouldn't be able to get the Batman ones where the people drill in through the center of the earth and come up underneath the, right? I wonder if that's ever actually really happened.
Center of the earth.
Well, you probably wouldn't have to go that deep. But, just get underneath the foundation. All right, so we have decentralized. And we have public transactions. So right off the bat, we have public oversight. Does that then give built-in security to the voting? Because there's plenty of people around the world that are interested in voting, right? Who we know don't agree with each other. Right off the bat, you're going to have the Democrat and the Republican Party setting up their own technology shops for watching the blockchain to make sure the other guys aren't up to anything, anything bad. Then you're going to have a couple of the other lesser parties setting up the same thing, because a lot of times those lesser parties, they know they're not winning any election, but they might actually play a big role in the election because they might take enough votes away from the person they don't want to win. That's their purpose. When you're getting 4% of the vote, you're not becoming a president. But you might keep somebody else from becoming president, and that's their goal. So you might have enough parties of people just at that level where there's oversight enough that we can say that's secure. And then we have a whole next layer of all the public who can sit there and watch it and literally tally votes themselves. And we'll know something is up if those vote tallies start coming up different. Right? And because there's a public record of the blockchain, we can look at it at any point in time. We can go and see that, it was manipulated right here. And catch. There's potential we wouldn't be able to catch who did it. But we at least would be able to see that it was done. And should be able to then reverse it. That make sense? Okay. So, what we're going to do in here first is we're going to use the Bitcoin blockchain. Then we're going to create our own coin and see how that blockchain differs. Go ahead.
How do you know that the blockchain was manipulated if someone has more than 51%? How you can identify?
Let me show you an example of. So we're going to be looking at this in a few minutes anyway. Actually, let's go to this one. So this is an example of a JSON object that has a bunch of transactions for a specific address. So assume this is going to candidate B, or something like that. We are looking at it at one point in time, but this guy exists thousands and thousands and thousands of times on the internet. When somebody manipulates the blockchain, there isn't a single entity called the blockchain. They're injecting into the system that manipulation and then letting it propagate. So there's a whole bunch of unmodified versions of it out there until it takes it over. So if people are constantly looking for this, they can compare blockchains until something changes. If somebody had 51% of it, more than half the time they could decide to make micro changes to the blockchain, and then when it gets distributed, because there is a source for every transaction, every 10 minutes a new block is added to the end of the blockchain. So it would be that block, the individual block that they are actually manipulating. Could you detect that? You can certainly detect if they rewrote the blockchain itself, because they have access to the blockchain because they have to add the block to the blockchain. But if they're just adding a block, okay, it would be more complicated, but you could still validate it. Just because the guy with 51% won the block, that means he decoded it first. Doesn't mean that others won't also decode it. Other entities will also decode it. They just didn't win. So they can finish decoding it, know what it should be, compare what it should be to what it is, and ensure that it is what it should be. I think I said the right thing. It just sounded really funny. But that would be a harder problem. Because at that point, we would be reliant on the oversight places to finish mining a block, even after they knew they lost. Where most Bitcoin mining software is set up, where once the block is done, once you found out that you were the loser, you stop looking at that block. Even though there isn't a great reason why we couldn't validate an individual block 1,000 times. We could have, 999 right answers, and the guy who won, wrong answer.
Doesn't the block have to be validated multiple times before it's actually added?
Transaction has to be validated multiple times. A block doesn't have to be A block doesn't have to be validated multiple times. It's on a per transaction basis. And that actually isn't part of the Bitcoin technology. That's part of the transaction technology. People on the endpoint decide at what point do they consider the money there. So for instance, CEX only requires 3 validations for a transaction for them to say, you have these Bitcoins. Whereas I think the standard is 6 validations. Typically you get 40 or 50 validations. And it kind of goes up over time because just like we were just saying, some people just keep going, or just out of sheer luck, you get enough people who kept going long enough extra to validate individual transactions but still lost the block.
That wouldn't play into this at all.
Yeah, but I still think that we have the opportunity for enough oversight. We still might need to convince several oversight bodies who we know are in conflict with each other to specifically mine blocks, knowing that they will ultimately get the block. They might not win, but they'll finish validating the block, which then they can confirm that the block that was added to the blockchain is in fact the correct block. So the idea is if somebody's always watching you, chances are you're not going to do something bad. If you're in Target, you're thinking about stealing a CD and a cop is standing right behind you, you're probably not going to steal a CD. That would be really stupid. Just like we don't speed when there's a cop right behind you.
I'm a criminal.
He goes faster when there's a cop behind him.
Just tear out in front of the cop.
I'll let him go.
All right, so we're going to look at this 2 different ways. We're going to start off by doing this over the normal blockchain. Then we're going to utilize the coin that we're going to be building in here called the Falcoin. That's going to be our vote coin from a blockchain perspective, and see how creating our own coin is so similar from a blockchain perspective. The biggest difference is going to be how do we access the blockchain. Any way you cut it, if we're going to count votes, last time we talked about that maybe 1 vote is 1 Satoshi. We've been talking about some different things like, okay, maybe the government has a whole bunch of Bitcoin and they distribute 1 Satoshi to each valid voter. Okay? And that's their 1 vote. Use it or not, right? So if they decide they want to pocket the Satoshi, so be it. Okay, use it or not. We only will accept votes from the authorized list of, I'm kind of getting ahead of ourselves as I'm actually telling you the solution to one problem. That's fine. I'm already down the path. When we're counting votes, votes only count that are 1 Satoshi in size and come from the list of registered Bitcoin wallets. That make sense? All right, so if all of you in here are distributed to 1 Satoshi, and all of you vote, because the government distributed you Satoshi, we've marked your address down and your address down as valid voting addresses. But we're only going to allow you to vote once. Once you voted from that address once with your 1 Satoshi, you're done. Okay, and the software we're going to use to parse the blockchain is going to take care of that. But now the question goes here. What keeps you from giving him your Satoshi? So now he has 2 Satoshis. And he hasn't cast his vote yet. So he's going to cast his vote with 2 Satoshis, which is going to be 2 votes.
But you only count 1.
Okay? Well, are we going to not count either of his votes? Are we going to say he voted with too many votes, so his vote doesn't count? What's accurate for voting? So let's say you decide to be unethical and sell your vote. So you've sold your vote to him. So now you've created a transaction where you send your Satoshi to him. Now he's going to come and he's going to vote with 2 votes. 2 Satoshi. He's got to do it in 1 transaction because we're only going to let him have 1 transaction. Okay? So we have a choice on our end. Do we say his vote doesn't count because he voted with too many votes? Or do we say, well, that one person voted, they voted this way, so now we're going to accept one vote from him? You can get around this right off the bat by saying, you're going to sell your vote to him, but instead of you sending a Satoshi to him, you just vote the way he tells you to vote. Right? Now we have two benign-looking votes coming in. Okay, is that just an innate problem with voting?
Yeah, I mean, I could tell him to vote for the election yesterday, any which way, if he doesn't care. So, I mean,
Yeah. So are we going to say that that's an acceptable problem with voting?
yeah, I mean, that can't be solved.
Okay. Go ahead.
No, I think that the government or the policy can just look for the other transactions that were not sending money for the two candidates and go after the guys. After all, they have the list of the public wallets and see, okay, you are sending your vote to
Okay.
someone
So-
who shouldn't.
If that one Satoshi that the government sent to each of you, instead of that going to your personal Bitcoin wallet, that went to your voting wallet, a voting wallet that was distributed to you by the government. It's still a public Bitcoin wallet. Okay, so it's not like the government can access your wallet or something like that. They've just distributed a unique identifier, one Satoshi associated with one unique hash address for a wallet. All right, now you can cast your vote from that. So with that in mind, if you try to send your Satoshi to him, we're going to be able to see that a transaction occurred that went to something other than the correct destination address, right? So we can come and get mad at you or whatever.
Since it's one Satoshi, just really care.
Well, yeah, we still got to deal with the problem. If he votes with two, probably just counted as one.
But you said previously that you only counted if it's the one Satoshi in size and to the correct wallet.
Fine, but is that right? So if State Farm votes with two Satoshi from the correct wallet, do we not count his vote as well?
I mean, I suppose you could. It doesn't really. It depends on just how you want to, establish the rules of voting using this system. I mean,
Okay.
I don't.
You could
I wouldn't say that's much of like. I don't think that like breaks this this process. I think that's more of just whatever you decide.
Okay.
That's your policy.
And maybe there's even a situation here where if we say that your vote won't count, if you vote with more than one Satoshi, then that's going to dissuade people from you requesting him send you a Satoshi to vote because now both votes don't count.
Well, I mean, and you can even just not care about the amount that's sent in the first place because you know that okay, you have the registered wallets, and they're going to be sending a transaction to one of the candidates, and so once they send a transaction, then they're not allowed to vote anymore.
Mm-hmm.
So that's their one vote is the transaction itself, and not necessarily the amount that was sent.
Okay. So any transaction to the correct wallet address from a
Registered wallet
counts.
counts.
Okay. Well, with that in mind, you actually don't even need Satoshis.
Yeah.
Because you can actually do a transaction that's just sending a message.
Yeah, the Satoshi is just the cheapest option.
Yep. But you can do it without a Satoshi. You could add something to the blockchain that has no value. You can use the blockchain for sending messages. That exists. And then we just mark off that. We would just mark off that problem or that vote once it came in. So now, a wallet address. So let's talk about the wallet addresses for a few minutes. So each of you is going to get issued a unique wallet address, right? So let's go down this path where you're saying we're going to, the vote is going to be based on just the source, the wallet. What keeps me from voting as you? This gets down to how wallets work.
You don't have the private key. You can send the transaction for you.
Okay, well, so we got to think about the security of this. If I'm the government and I'm distributing the wallets to you guys, how are you going to use those wallets? Do I set up a website? Kind of like blockchain.info where you can log in and get into your wallet here and go and do stuff. So we're going to trust the government's website?
If you're their healthcare one, probably not.
Because now we have multiple points of failure, right? So all of you have gotten your voting wallet ID, your username and password to get into your wallet. You all go through the same website, centralized portal. You've logged in, you vote, and behind the scenes you don't know if it sent it to the right address or not. You just believe that it did. Right? Go ahead, you had something?
Yeah, I was gonna say that with us all having our own wallets, who's to stop us from just giving the information of our wallets to somebody else? Like selling the actual account with all the information attached to it and giving somebody else 2 accounts to vote on, even though they're representing 2 different people.
That's true, but we talked about that already, where it's like that's just a problem with voting. There's no difference between you giving him your wallet login information or just you agreeing to vote for the person he tells you to vote for. Those are the same thing, basically. He can cast 2 votes himself using his wallet and your wallet, or he can cast 2 votes himself using his wallet and asking you to vote with your wallet the way he wants you to vote. And that's just a problem with voting. It is actually kind of interesting that you don't see people overtly selling votes with elections. Like, I'm surprised people don't sell their votes on eBay and stuff. I mean, I realize eBay would take it down right away, but I'm just surprised there isn't like a market for that. Or is there?
The guy the other day, James O'Keefe, I mean, this obviously doesn't prove anything. He's more or less just demonstrating that you can, like, vote without an ID. It's very easy. Well, I wouldn't say it's like very easy, but it's certainly possible. Because he voted, well, he didn't vote 20 times. He got like 20 ballots.
So he kind of proved the system is faulty.
Yeah. That there's the potential for people to take advantage of that. He didn't necessarily prove that it's happening.
Mm-hmm. So we're just going to say that that's a problem with voting. That you might have 2 people who you might have one person who casts a vote twice, but at least they're going to be casting the vote twice through legitimate means. You know, if he convinces you to cast a vote for him, you know, for the way he wants you to vote, that's on your guy's conscience. You know, it's actually kind of an interesting side thing is, shouldn't we be allowed to sell our votes on eBay? And I realize it's unethical and stuff like that, but I mean, it's our vote, right? And let's just talk about something important like a presidential election. It's our vote. Is there anything that says that we have to use it to vote our opinion?
Probably some way.
You think?
Well, there's only a couple choices. You either vote for the candidates that are on the ballot, fill in the little spot that says other.
Well, no. Let's say that I wasn't going to vote. Okay, so I'm not going to vote anyways. I'd be certainly willing to take some cash to cast a vote, right?
I guess that's where.
So if somebody wants to come and give me $1,000 to put a little check mark on a ballot.
But that's where a single wallet would come into play. Like, instead of having multiple wallets with dispersed values, a single wallet with all of the voting in it.
Well, you're talking about the Bitcoin stuff. I'm really talking about just normal voting. Like, why can't we sell our votes in the real world? I don't think you can. I think it's illegal.
There's no value to a vote, though.
Sure it is.
Not to you. I mean,
To other people. If you're crazy for candidate A and you're willing to pay people cash to vote for candidate A,
The problem is, I think that you have to get enough votes to make that effective. You would have to fork up a lot of money. Like $1,000 for one vote, that's not going to do anything. You're going to need thousands of votes, so that's hundreds of thousands of dollars that someone would need to pay.
who cares? Hundreds of thousands of dollars is chump change when you consider how much these politicians are spending on campaigns.
But when people start making that a public thing, you're gonna want to ask for more money before.
Oh, then it drives the price up.
Yeah, then it drives the price up,
Yeah.
and then it gets even more expensive.
Yeah, but even then, they'll just make it back on their earmarks on the on legislation. It's like, oh, okay, well, I just spent $1.5 billion buying your way into office. So, what have you done for me lately? Yeah, I'm not sure there's necessarily a way around that. That's more just human corruption. That's not a security thing, really. So the thing that we want to focus on in here is accurately counting votes in a public forum. You know, there's problems that we just cannot solve. We can't solve human beings being unethical. We can solve the problem of having each wallet address making one vote. But how do we solve the security problem? Let's go back to our slide here. When our people vote, see, they're going to go through some portal. This is the bad way of doing it, but we'll. So every one of you has been given a username and password. Let's just say, some sort of authentication information for you to go to this website and use your vote. Maybe it's a hash value. You go in, you plug in, and that's your vote. Maybe it's a username, password. Maybe it's some combination of your social security number and a bunch of other pieces of information proving you are who you are. And if you think about it, we already have a precedent for that level of security. For instance, logging into your bank is substantially harder than logging into iTunes. Correct? Your bank asks for usually 2 or 3 different forms of identification. You have to answer, other questions. So there's already a precedent for pretty good protection getting logged into this portal. But if the government wrote this portal, and we're going to assume everybody, we just keep saying the government, if the authority over this election made this portal, and all of us are going to go to this to cast our vote, what keeps them from manipulating the votes prior to it being thrown on the blockchain? It gets thrown on the blockchain once a Bitcoin transaction occurs, correct? Actually, it gets thrown to the miners to be thrown onto the blockchain. But before that even happens, a transaction needs to be born from that portal that says, send 1 Satoshi to this destination address. Well, what keeps this portal from sending it to different destination addresses? You vote for candidate A, it actually sends it to candidate B. Publicly, it can tell you it sends it to candidate A. Thank you for voting for candidate A. Meanwhile, it just sent your vote to candidate B.
Make the code open source?
Huh?
Make the code for portal open source?
Well, just because the code's open source doesn't mean that this install of it hasn't been modified. You kind of see the rabbit hole of security problems we run into here. So what we're going to talk about next time, and I'll throw a slide up here, is Bitcoin wallets. Cloud-based, local-based. We can each have our own wallet that only we control locally on our machine. Okay? We don't have to go through this centralized place, but that comes with convenience issues. All right, so we'll talk about that on Friday.